Hi everybody, in this video we're going to recap the topic from this past week, which was on writing the equations of parallel and perpendicular lines and writing the equation of a perpendicular bisector. So let's start off with parallel and perpendicular slopes. So what we're going to do is we're going to determine if the slopes of these sets of equations are parallel, perpendicular, or neither. So if I take a look at the first one from the graph, I see the lines are parallel. They go on forever in either direction. They never intersect. They never meet each other. So I'm going to write that these lines are parallel. And notice that their slopes are the same. Remember when we have a line in y equals mx plus b form, the m represents the slope of the line. So these lines are parallel, and we can write down parallel lines have the same slopes. Taking a look at the middle set of equations, from the picture, I see that they do intersect, but they don't intersect to form right angles. So I can't say they're perpendicular. So I'm going to have to go with neither. Now, if I want to see if the slopes have a relationship, I really can't, because unlike the first example, we don't have our equations solved for y. So I'm just going to go ahead and divide everything here by 2. And that gives me y equals to 3 over 2x plus 3. I'm going to go ahead and divide everything here by 4. And that gives me y is equal to x over 4, or 1/4 x, minus 2 over 4, which simplifies to 1/2. Looking at the slope, we have 1/4 and we have 3 over 2, and there does not appear to be a clear relationship. Let's move on to the next one. I see from the picture that these lines appear to form right angles. So I'm thinking these are going to be perpendicular. And remember, that's the symbol for perpendicular lines. Let's take a look at the slopes. We have 1/2 as the slope in the top line, and we have -2 as the slope in the bottom line. If I put this over 1, it's easier to see the relationship between the two slopes. Let me just write that 2 again so we can see it. There we go. Notice how this slope is the same numbers as this one. It's just flipped. So the fraction flipped and the sign changed from positive to negative. We call this an opposite reciprocal slope or a negative reciprocal slope. You're going to hear me refer to it as an opposite reciprocal slope, but negative reciprocal is the same thing because the signs changed. That's the opposite part. And the fraction flip. That is the reciprocal part. So I'm going to write that here. Perpendicular lines have opposite reciprocal slopes. For each set of equations, we're going to do the same thing. We're going to determine if they are parallel, perpendicular, or neither. In line A, I can clearly identify the slope. It is 3 over 5 because that's already in y equals mx plus b form. Line B, I need to solve it for y. So I'm going to do my equation. And what I'm going to do is I'm going to divide everything by 5 to get y by itself. And I see here that my slope is 3 over 5 as well. So I already see line A is parallel to line B. They have the same slopes. Parallel lines have the same slopes as each other. And then finally, I'm going to solve out line C for y. So we have 10x minus 6y is equal to -4. I'm going to subtract 10x from both sides to move it away from the y term. Oops, -4. My bad, that's a -4 that we have here. And then finally, I'm going to divide by -6 to get y by itself. So that is positive 5 over 3x plus 2 over 3. So I see the slope of line C is 5 over 3. Now you might be thinking, oh, that's the reciprocal of the slopes in line A and B. If you flip 3 over 5, you do get 5 over 3. But is it the opposite reciprocal? It is not, because the sign didn't change. So we can't say that line C is perpendicular to lines A and B because it doesn't have an opposite reciprocal slope, just a reciprocal slope. So I would say that line C does not have a relationship to line A and B. It has a neither relationship. Okay, set 2 real quick. If I solve out the first one, I'm going to take my line here. I'm going to move everything away from the y term. And I'm going to divide everything by -3. It's a 4. There we go. Line B. Let me use a different color for that. Let me write it down. Okay. And finally, dividing everything by 4. So I already see line A has a slope of 4 over 3. Line B has a slope of -3 over 4. Notice that these are opposite reciprocals. To get from the slope to the slope, the fraction flipped and the sign changed. So I'm going to write line A is perpendicular to line B. Let's see if line C has a relationship to either of the other lines. So let me write down the equation, and we will move everything away from the y term. And lastly, we just need to divide everything by 4. Let me get a little bit more space here. So we have y is equal to 3 over 4x plus 5. So I see that the slope is 3 over 4. That line doesn't appear to have a relationship with the others. It's not the same as -3 over 4, so it's not parallel to that. And it's not the opposite reciprocal of line A, it's just the reciprocal. The signs are the same, so it's not the opposite reciprocal. For each equation, we're going to determine what the slope of the line parallel to it would be and what the slope of the line perpendicular to it would be. So my first step, just like before, is I have to make sure that my line is in y equals mx plus b form so I can clearly see the slope. I'm going to distribute out real quick. So I have y minus 2 is equal to 1/3 x. 1/3 times -3 is -1. Adding 2 to both sides, we have y is equal to 1/3 x plus 1. So here we have our slope is 1/3. The parallel line slope would be the same slope. Parallel lines have equal slopes. The perpendicular line slope would be the opposite reciprocal. If I flip the fraction, I have 3 over 1, and the opposite part means make the sign different. So that would be -3 over 1, or for short, just -3 for the perpendicular line slope. Let's try it again in the next example. Once again, I'm going to just distribute out. Minus, the 4's cancel out, so that's -3. And I can finish up by adding 5 to both sides. We see that the slope is -3 over 4. So the slope of the line parallel to it would be the same thing. Parallel lines have equal slopes. The perpendicular line slope would be the opposite reciprocal. So flip the fraction and change the sign. If it was negative to begin with, now it's positive. So you might have also noticed that we didn't have to do all that solving out to see what the slope is. The slope of the line ended up being right here, outside of the parentheses. That's because the equations of these lines are written in something called point slope form. Point slope form, and we'll talk about this later on, is a way of writing the equation of a line. I'm going to write it down here, point slope form. And in point slope form, the slope is outside the parentheses. And then we have the x and y coordinate of a point on the line. We're going to see on the next slides how point slope form can be a really, really useful way for writing the equation of a line and cut down on the work that we would normally need to do if we were writing the equation of the line in y equals mx plus b form. So now we're actually going to write the equation of the line parallel to the given line passing through the given point. So I paused the video for a second so I could make myself more space because I didn't have space for this one. So we're only going to do one of these. So we'll just do the first one and then we'll move on to the next slide. So we want the equation of the line parallel to the given line, the line that they give us, that passes through the given point. Parallel lines have equal slopes. So if the slope of the original line is negative 3 over 5, we're going to be using the same slope for the parallel line. We also have a point. When we have a point and a slope, it's super useful to use point slope form. Point slope form for writing the equation of a line. Point slope form, once again, is y minus y1 equals to m, x minus x1. All you need to do is plug in the x and y coordinates of the point that you're using and your slope for m. So here, our y coordinate of the point that we're using is negative 1. Our slope is negative 3 over 5. And our x coordinate of the point that we're using is 5. And we can actually just leave our answer like this. And that is a perfectly fine and good equation of the line. This is really, really useful on short answer questions. Specify what form your answer has to be in. If it doesn't say slope intercept, if it doesn't say y equals mx plus b form, why do more work than we have to and run the risk of making a mistake in our solving? If we wanted to solve for y and put it into slope intercept form, or y equals mx plus b form, we could do that by just distributing. One more step. And this would be an equivalent equation of the line written in slope intercept form, written in y equals mx plus b form. We're going to do the same thing to write the equation of the line perpendicular to the given line, passing through the point negative 6, 4. So first, identify the slope. I can't see what the slope is because this equation is not written in y equals mx plus b form. I'm just going to go ahead and divide everything by 3 to put it in y equals mx plus b form. Now that it's in y equals mx plus b form, I can see that the slope is 2/3. So we need the slope of the line perpendicular to this one. And we know that perpendicular lines have opposite reciprocal slopes. So I'm going to flip the slope of the original line, the reciprocal, and I'm also going to make it opposite. I'm going to change the sign. And this is going to be the slope that we're using for our perpendicular line, our line that we're writing. Now I have my slope, and I was given my point in the question. So I have everything I need to use point slope form to write the equation of the line. All you need is, like the name, a point and a slope. Slope form. So I'm going to head on over here and I'm going to write down point slope form, and I'm going to just plug in. Y coordinate of my point is 4. My slope is -3/2. X coordinate of my point is -6. And once again, I can leave my answer like this. This is a perfectly good and valid equation of the line. It's just written in point slope form. But if I wanted to take it a step further, if the question asked, I could definitely distribute and solve out. This is a minus minus, so that makes a plus. And that is 18/2. 18/2 is 9. So I'm just going to change that to 9 so I don't confuse anybody. And then I'm going to finish this up by adding 4. And there we have it, an equivalent equation of the line. So both of these are correct. They are the same equation of the same line, just written in different forms. One's written in point slope form, and one's written in slope intercept form, in y equals mx plus b form. I personally think it's a lot easier to leave it in point slope form. All you need to do is plug in your point and your slope, and you're good to go. Okay, let's take a look over here at the next one. We're going to find the midpoint of the line segment with endpoints -2, 4 and 2, -4. So to find the midpoint, I'm going to use midpoint formula. I'm going to average the x coordinates, and I'm going to average the y coordinates. So my x coordinates are -2 and 2. My y coordinates are 4 and -4. So it turns out that my midpoint is 0/0. Anything divided by 0 divided by anything is 0. So I'm going to mark that on the graph because they give us a graph here. Our next step, it says, is to write the equation of the line perpendicular to this line segment that passes through the midpoint we found. So we know how to write the equation of a line, especially in point slope form. We have our point, that's our midpoint, that's the point we're going to be using here, and we just need our slope. Unfortunately, we don't have the equation of a line to get the slope from, but what we do have is 2 points. So I'm going to go over here on the side, and I'm just going to find the slope of the 2 points. And I can do that using slope formula, which you probably remember from class and from algebra 1. So I'm going to subtract my y coordinates, and in the denominator, I'm going to subtract my x coordinates. And I got -8/4, which is -2. So if our slope of the original line segment is -2, we need our perpendicular slope, which would be the opposite reciprocal slope of -2. If I flip -2 and I change the sign from negative to positive, I get 1/2. All that's left for us to do is use our point and our slope to write the equation of the line. So I'm going to write down point slope form once again, and I'm going to just plug in. The y coordinate of the midpoint, the point that we're using, is 0. Our slope of the perpendicular line was 1/2, and our x coordinate of the point that we're using was 0. Once again, this is a perfectly good and valid equation of the line. We can leave it like that for a minute. But part it does say the graph the new line that we found. In order to make our life easier with graphing, I am going to put this in y equals mx plus b form. So y minus 0 is y. If I distribute the 1/2, I have 1/2 x. 1/2 times 0 is 0. We have a y-intercept of 0. So we're going to start at 0 while graphing on the y-axis. We have a rise of 1 and a run of 2. So that tells us we're going to go up 1 over 2 to graph a point, up 1 over 2 to graph another point. To get points on the other end, we can do the opposite. Down 1 over 2, down 1 over 2. Let me connect those together so we can see the line. And let's take a look at what we know this. The lines are perpendicular. We used opposite reciprocal slopes, so we knew that we were making perpendicular lines, which form right angles. We also know that our new line goes right through the midpoint of the original line segment. If it goes through the midpoint, it's cutting the line segment in half into 2 equal parts, or bisecting it. So what we actually just found the equation of is we found the equation of the perpendicular bisector of the original line segment. We're going to do one more example of writing the equation of a perpendicular bisector. We're going to follow all the same steps that we did in the previous example. So we're told we're writing an equation of the perpendicular bisector of a line segment whose endpoints are -1, 1 and 7, -5. So I'm just going to make my XY coordinate grid here. -1, 1 is right here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5 is right here. I'm going to connect those dots together with a line segment. So I know that the perpendicular bisector needs to pass right through the middle or through the midpoint. So first I'm going to find the midpoint of the line segment. So just before, I'm going to average the x coordinates, and we're going to average the y coordinates. And that gives us 6 over 2 is 3, 4 over 2 is 2. 1, 2, 3, 1, 2. My mistake. I graphed this point incorrectly. I graphed 7, 5 instead of 7, -5. So 1, 2, 3, 4, 5 would be right here. And let me get rid of that and connect with this. And now we can see that the midpoint, 1, 2, 3, 1, 2, does appear to be in the middle of the line segment. Now that we have the midpoint, we have the point the line is going to pass through. We just need the slope. So in order to find the slope, we can either use rise over run. If I count 1, 2, 3, up, 1, 2, 3, 4, 4 to the left. The left is in the negative direction. So my slope is -3 over 4. If you're having trouble seeing that graphically, you can always use slope formula, which is change in y over change in x. We can plug into that really, really quickly and see that we get the same thing. Our y coordinates are -5 and 1. Our x coordinates are 7 and -1. We have -6 over 8, which simplifies to -3 over 4. Since it's a perpendicular bisector, we need perpendicular slope. The slope of the line perpendicular to this one. So I'm going to write that down here. Perpendicular slope would be the opposite reciprocal. So we're going to flip the fraction, the reciprocal, and since it's a negative, the opposite sign would be positive. Now that we have our point, which is our midpoint, and our slope that we're using, we can write the equation of the line. I'm going to go to point slope form, just like before, and I'm just going to plug in the y coordinate of the midpoint that I'm using is 2. My slope of my perpendicular line is 4 over 3. And the x coordinate of my midpoint, the point that I'm using, is 3. This is a perfectly good equation of the line. You do not have to solve for y if the question doesn't specify. But I will just so I can graph it for you. I'm just going to distribute the 4 over 3. And then I need to add 2 to both sides. And we have y equals to 4 over 3x minus 2. The y-intercept is -2, so that's going to be my starting point for graphing. The rise is 4, 1, 2, 3, 4, 1, 2, 3 to the right. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And we can see that our line is the perpendicular bisector of our original line segment. Okay, we're going to write down these steps on the next slide so that we have some more space. So let's write this down. Steps for writing equation of perpendicular bisector. First step, we need our point, which is going to be a midpoint because a perpendicular bisector is a bisector, so it passes through the midpoint of a line segment. So find the midpoint of the original line segment. Step 2, we need our slope. So you can use slope formula, or if you have a graph, you can use rise over run to find the slope of the original line segment. Once you have the slope of the original line segment, since this is a perpendicular bisector, you do need the opposite reciprocal slope. Take the opposite reciprocal slope. And once you have a point and a slope, you can write your equation of the line using either point slope form or y equals mx plus b. I highly recommend point slope form. It cuts down on the work that you need to do, just like we were doing in this video. So using your midpoint and using your opposite reciprocal slope, write the equation of the line. Using the midpoint and the opposite reciprocal slope, use point slope form to write the equation of the perpendicular bisector. I'll zoom out so that you can see all of these steps at once.